Hello everyone. Today I'm going to make an attempt to explain the topic atomic structure and make it as easy as possible. Now, in this chapter atomic structure, we are going to discuss in detail what atom was proposed to be in the initial stages in prehistory of science by Dalton's atomic theory. We are going to discuss about the invention or discovery of electrons by J.J. Thomson, followed by J.J. Thomson's model of an atom. We'll be discussing about Rutherford's model of an atom, Bohr's model of an atom, Sommerfeld's model of an atom, and we'll conclude with the modern concept of atomic theory. In due course, we will also be discussing about the quantum numbers and rules to be followed while writing electronic configuration. First, let us know about Dalton's atomic theory. John Dalton, a scientist, he was the first person who John Dalton was the first person who attempted to describe the structure of an atom. Okay. Now, how did he describe that? Why did he even think about it? See, to know about the properties of any substance, it is very important to know how the particles that are making up that substance behave and what are their properties, how do they look like, and what is their behavior. So this urged our scientists to learn the structure of atom. Now, the very first person who actually proposed that everything around us is made up of tiny particles was an Indian sage, a philosopher, Kanva Maharshi, okay, who stated that everything around us, everything which is around us is made up of tiny particles called Anu and Paramanu. Later, it is Dalton's atomic theory because these philosophical things are needed to be supported by science. And at that time, they don't have the practical approach to justify the statement. So they remain as they are. Now, Dalton was the scientist who actually proposed that atoms are tiny particles which cannot be seen with the naked eye, okay, and they are indivisible. So atoms are tiny, indivisible particles which make up matter. He also stated that atoms of the same type will be having same properties in all respects. For example, if I take two atoms of hydrogen, both hydrogens will be having same physical properties like atomic size, and they both will be having same chemical properties. For example, if one hydrogen is reacting with, or say two hydrogen atoms are reacting with oxygen to form water, the other two hydrogen atoms also will be reacting with with oxygen only to form water. So the chemical reactivity, the chemical properties will remain same. That is what Dalton stated. He also proposed that these atoms, okay, of the same kind or different type, they combine with each other to form compound atoms, which are later termed as molecules. So this is what Dalton stated. The first thing Dalton stated was atoms are made up of tiny particles which are indivisible, and some books also say that they are elastic. Okay, and atoms of the same type will be having same properties in all respects, and atoms of different type will be having different properties in all respects. Now these atoms, as they are indivisible, but they combine with other atoms of the same type or different type to form a compound atom or a molecule. Now, after that, there was a scientist who invented discharge tube. Name of the scientist is William Crook. So William Crook, he invented a discharge tube. A discharge tube is nothing but a long glass tube which is either partially or completely evacuated, which has two electrodes at both ends, and these two electrodes are connected to a very high potential, a high voltage. This high voltage ranging up to 10,000 volts. Okay. When this potential is applied and the air inside this discharge tube is pulled out, we notice that this is what was discovered by William Crook. Then J.J. Thomson was the scientist who was performing an experiment to know the conductivity of air, whether electricity can pass through air or not. Now, at that point of time, he made a small opening. He started evacuating the discharge tube. Okay. And then at this high voltage, when the pressure has gone to 0.01 mercury mmHg, he noticed that there is a bluish green beam of light. Okay, there is a bluish green glow in the discharge tube. This clearly indicated that there is something going on inside the discharge tube. Fine. Then they wanted to know, he wanted to know what actually, like, from where it is actually coming. He noticed that when a slit is nothing but a narrow gap, a narrow opening through which something can pass, is arranged in middle of the discharge tube. From the negative terminal to the positive terminal, the beam was traveling. How we know that? It's very simple. The beam which is coming from that side, it stops after striking the obstacle, but only through the narrow opening they'll be able to pass. This clearly explains that they are coming from the negative terminal to the positive terminal. Okay, so we understood that. Now, we know that atom is an indivisible particle according to Dalton's atomic theory. Remember, we were still following Dalton's atomic theory by this time. Okay, so what happened? These electrons are like not electrons yet. We are having something coming from the negative electrode to the positive electrode. So what is coming? Is it that the gas or the air which is there inside it, it has got charged up? If it has got charged up, then how did it get charged up? Like, what is it made up of? It is breaking into pieces, isn't it? The air which is in middle is breaking into pieces, or there are electrons, there are some particles which are coming from the negative electrode to positive electrode. That means this negative electrode is giving off some particles. Those particles are negatively charged electrons. So J.J. Thomson was the scientist who discovered these particles, and G.J. Stoney. J.J. Thomson is a scientist who discovered these electrons, and G.J. Stoney is the scientist who named these particles as electrons. Okay. Now, as it is, a new particle is discovered. Now it is on the responsibility, this responsibility of describing how the atom is and how these particles are arranged in the atom is again on scientists. So this is where J.J. Thomson has given his model of an atom. J.J. Thomson's model of an atom can be compared with watermelon, or he also compared it with plum pudding. Okay, just like we have watermelon, which is completely filled with fiber, and we have seeds scattered in it. In the same way, atom is also an aggregate of positive charge in which negatively charged electrons are scattered in all directions. That is what he stated. Okay, now, after this model of an atom was proposed, it was accepted for a few days, but still it has its own drawbacks. It could not explain how the bonding is formed, how atoms are combining to form a new bond. Now, during this course, Rutherford was the scientist who was actually working on the penetration power of different particles. Okay, this is where we come across a very famous experiment called Rutherford's alpha particle scattering experiment. alpha particle. Excuse me. Okay, alpha particle. What is an alpha particle? An alpha particle is nothing but double ionized helium atom. Okay, to know this, we need to know what ion is and what ionized atom is. See, every atom will be having electrons in its shells. Okay, first let us understand that we are in the modern period. Every atom will be having electrons, and these electrons are revolving around the nucleus. Now, if the outermost shell has 8 electrons, then we say that atom is stable. Why it is stable? That we will see as we proceed in the later part of the video. Okay, if the atom is having 8 electrons in the outermost shell, then we say that atom is stable. Okay, to attain that stability, okay, to have that 8 electrons in the outermost shell, these atoms can either lose electrons or gain electrons. For example, if I take the example of calcium, calcium has an atomic number 20. It has 2 electrons in the first shell, 8 electrons in the second shell, another 8 electrons in the third shell, and it has 2 electrons in the fourth shell. In the last shell, there are 2 electrons. That means it is not having 8 electrons. It is falling short of 6 electrons to attain stability. Now, this calcium has 2 options. Option number 1, it can lose these 2 electrons. So when these 2 electrons are given away, it has only only the third shell is the last shell, and this last shell is having 8 electrons, so it is stable. That is one method. Option number 2, it can gain 6 electrons. When it is gaining 6 electrons, okay, does it have the potential to hold those many electrons? Remember, gaining electrons is fine. It may get electrons from any of the neighboring atoms of different element, which is ready to give the electron away. But the nucleus also should be having the energy to hold those electrons with it. Okay, so that is difficult in case of any atom. So what this calcium does, it gives away 2 electrons. So calcium, which has 20 protons and 20 electrons, okay, it gives away 2 electrons, after which it will be having 20 protons. It gave away 2 electrons, so it will have only 18 electrons. Now let us look at the charge. Initially, it is plus 20, minus 20, so total charge is 0. Understood, every atom is neutral. Now, after giving away the electron, we see it is plus 20, minus 18, so that is plus 2. This is the reason why we write calcium ion as Ca2 plus ion. Okay, so this is how we got. And this process of losing electrons is making the ion into a charged particle. This charged particle is called ion. So we can define ion as an atom either loses or gains electron to become a charged particle. That charged particle is called ion, and the process is called ionization. The process in which an atom either loses or gains electron to become a charged particle is called ionization. And the energy required to remove the electron from the outermost shell of an isolated neutral atom, the minimum energy required, is called ionization energy, about which we'll be learning in the later period. Okay, so coming back to alpha particle. An alpha particle is defined as double ionized helium atom. That means an helium atom which is ionized twice. What is the atomic number of helium? Helium atomic number is 2. That means it has 2 protons, 2 neutrons, and 2 electrons. So mass is 4. Okay, now I ionize it once. So what does it give me? That means I took 1 electron away. So it gives me He plus ion. Okay, which has 2 protons, 2 neutrons, and only 1 electron. Now this He plus ion, it will again give 1 more electron to give me He2 plus ion. This He2 plus ion is alpha particle. Okay, this He2 plus ion is called the alpha particle. Now, Rutherford was penetrating these alpha particles. He was making the alpha particles penetrate through different elements. Okay, and he understood something which is very peculiar, very different, like which is not expected. Okay, what was that happening? He took a source of alpha rays. Okay, he allowed them as a form of beam. Okay, he collimated them. This process of converging all light rays into a single beam is called collimating. Okay, you will be learning about a collimator in your higher classes. Now, he made these light rays to fall on a gold foil, a very thin layer of gold, and he surrounded this gold foil with sensors by which, if when they strike and they get deflected, they should be able to produce a scintillation here. Remember, I used the word sensor according to the new technique we have and the technology available, but Rutherford actually used the zinc sulfide screen. Zinc sulfide screen produces a fluorescence. That means whenever these kind of charged particles fall on that, they produce light. So they produce a very small spark of light, which he need to understand and study. Okay. So he noticed that some particles after striking, they are coming back. Some are getting deviated. We see these deviations being very odd, and there is nothing which is trying to travel along the same straight line path. What does it explain? Now, these deviations were first understood in a different way. Okay, it was understood that according to J.J. Thomson's model of an atom, we have atom like this that is completely filled with a positive charge. It has electrons scattered, and these alpha particles are traveling undeviated, so not a problem. If this alpha particle is striking an electron, then it is deviating. That is what first was understood. But Rutherford considered only one atom of gold, and then he started studying the variations in the atom or variations in the path of the alpha particles because of that atom. From here, we got Rutherford's alpha particle scattering experiment over a gold foil, or simply Rutherford's gold foil experiment. Now, if we consider an atom, okay, and these alpha particles are traveling along this path, we notice that these particles are going undeviated. The particles which are traveling far from the center of the atom or far from the atom either, they are going undeviated. Now, alpha particles which are coming towards close to the center of the atom, they suffer a little bit of deviation. And alpha particles which are trying to come close to the center, they are undergoing a higher angle of deviation. and alpha particles which are trying to travel exactly through the center of the atom, they are bouncing back, they are retracing their own path, they are bouncing back along the same path. Okay, now why is this happening? A simple analysis. We know alpha particle is positively charged. So that positively charged alpha particle, if it is trying to travel through the center, only then there is a repulsive force acting and it is bringing the or deviating the positively charged alpha particle away. In any other case, it is either deviation or no deviation at all. Okay, from this we understand that there is something in the center which is positively charged. Okay, or rather, by the time already Goldstein has discovered protons. Okay, so what Rutherford stated is that the entire positive charge is concentrated at the center, that also in a very small area. Okay, so the entire positive charge is concentrated at the center of the atom in a very small area or small region, and that he called it as nucleus. Okay, and because alpha particle is positively charged and the nucleus is also positively charged, there is a repulsive force that is acting and it is pushing the alpha particle away. So based on this, Rutherford gave his model of an atom, which is called Rutherford's planetary model of an atom. Okay, Rutherford's planetary model of an atom. In this, Rutherford compared his model of an atom with solar system. Okay, he stated that atom is spherical. Just give me a minute. Okay, Rutherford stated that atom is spherical in shape and almost hollow. The entire mass of the atom is concentrated at the center of the atom, which he called it as nucleus. He also stated that the size of the nucleus is very small when compared to size of the atom. Okay. Now, nucleus consists of protons and neutrons. That is what he stated. And he continued saying that negatively charged electrons revolve around the nucleus just like planets revolve around the sun in circular orbits. You will know why I said I emphasized on the orbits being circular. He stated that atoms are revolving around the nucleus in circular orbits. Now there are two forces acting on any body which is moving along a circular path. Okay, one force is the force which attracts the electron towards the center. That is called centripetal force. Okay, that is called centripetal force. And that force, that centripetal force on the electron is because of the force of attraction between the electron and the nucleus. Now, when a body is moving continuously along a curved path, a tangential force develops in it. A force which will be pushing the body away from the center will be developing along the tangential path. I hope you all know what is a tangent. A tangent is a line which is touching the circle only at one particular point. And if you draw a line from the center of that circle to the tangent, which makes the radius, it will be perpendicular to the tangent. Okay, so this tangent, the force will be acting along the tangential direction. Okay, and that force is called centrifugal force, which is push away force. It pushes the body away from the center of the circular path. Now, Rutherford stated that the centripetal force, that is because of the nuclear force of attraction, is equal to the centrifugal force of the electron. The centrifugal force is developed in the particle because of its high velocity. As these two forces are equal and opposite in direction, the electron continues to travel along a circular path around the nucleus. That is what he stated. Now, this is where classical mechanics stepped in. Classical mechanics had a question to Rutherford, and it asked, if a body has to move continuously, it should lose its energy. Now, this electron, which is moving continuously, also has energy, which is obviously kinetic energy. Every moving body will have kinetic energy. Now, the question that raised is, here, if the body is continuously losing its kinetic energy, then the centrifugal force, the force which is pushing the electron away, is decreasing. As it is decreasing, what should happen? The centripetal force, that is force of attraction, should dominate. And as the force of attraction dominates, automatically the electron should be traveling along a curved path. It should not be traveling in circular path anymore. It should be traveling along a curved spiral path and fall into the nucleus. That means electrons, protons, neutrons, everything should be lying in the same region, which is not actually happening. And because this is taking us back to Dalton's atomic theory or J.J. Thomson's model of an atom. So that is not actually happening. So this is one drawback of Rutherford's model of an atom. Okay, now to correct this, to rectify this, the scientist who came forward, who stepped forward, was Niels Bohr. Niels Bohr actually revolutionized the concept of atomic structure. Okay, the statements which he made, not only the statements he made, but the way he explained the concept of atomic spectrum with the help of hydrogen atom was so wonderful that he was actually given with a Nobel. He was awarded a Nobel Prize for his efforts in chemistry and explaining the structure of hydrogen spectrum. Okay, now what did he actually state? In this, he explained. Niels Bohr stated that Niels Bohr stated that atom is spherical in shape, which has positively charged nucleus at the center. It has electrons and protons at the center of the atom. Electrons revolve around the nucleus in circular orbits. Okay, until here it is same as what our Rutherford said, and here this is the point, this is the place where actually there is a small change. Instead of saying that the electron is having energy, here Rutherford said that it is not electron that has energy, it is actually the shell or the orbit that has energy. He named these circular orbits as shells, and he also gave them names like K, L, M, so on, or 1, 2, 3, so on. Okay, now he stated that the energy that is possessed by these electrons, these shells, is constant, it is fixed. So we call these as stationary shells or stationary orbits. As the energy is fixed, he called them as stationary shells or stationary orbits. Now, he also stated that as long as the electron is revolving in the same shell, as long as the electron is present in the same shell, an atom neither loses nor gains energy. The energy remains the same. Again, this is one more reason why he called it as stationary shells. Energy is neither given out nor lost as long as the electron is revolving in the same shell. He stated that the shell which is close to the nucleus will have less energy, say E1, and the shell which is far from the nucleus will have more energy, and which is farther more away from the nucleus will have much higher energy, in such a way that E3 is greater than E2, which is greater than E1, or E1 is the least amongst all energies. If electron is jumping from the first shell to second shell, jumping of electrons, here I would like to introduce or just mention about a concept called thermoionic emission. Thermoionic emission. Thermo means heat. Ion means a charged particle. Emission means coming out. Okay. Remember, science is simple. Let us keep it simple. So, because of heat energy, electron is coming out. This is what actually many scientists have used, and they mentioned it is not something which I am trying to make simple only. I'm not proposing this. Okay, if we take any sheet of metal and I allow a beam of light to, or a beam of energy source, light to fall on that, or rather, we say the thermoionic emission. Let us say we heated it. When we are heating a metal substance, what happens? The particles which are directly exposed to the source of heat energy, they are absorbing the heat and following law of conservation of energy, which states that an energy can neither be created nor destroyed. What they do, they increase their kinetic energy. We say in solids particles cannot move. Yes, they cannot move, but they can vibrate within their mean position. Okay, in the same way, electrons, they absorb that energy. They start revolving with a higher velocity. When they start revolving around the nucleus with a higher velocity, what happens? They also move away from the nucleus. Let us take one example. If I take a small stone, tie it to a spring or a rubber band, and I try to move it. When I move it, you see the rubber band gets stretched. Now what I do, I try to rotate it with more speed. Then what happens to the stone? It gets stretched and it starts moving in a larger radius. Okay, that means if the velocity is increasing, it is moving away from the center, which is my hand. The same thing is applicable here also. When we are heating, when we are giving some amount of energy, and this energy can be coming in form of heat energy, light energy, electromagnetic, whatever it may be, the energy which is absorbed by this electron which is in the first shell, what it does, using that energy, it will increase its kinetic energy. When the kinetic energy increases, it starts traveling with a larger radius, so it will jump from the first shell to second shell. So that statement, to understand that statement, that upon absorbing energy, electron jump from inner shell to outer shell. This is the concept. Okay, so whenever we are supplying energy, electrons will absorb that energy. Law of conservation of energy states that energy can neither be created nor destroyed, but it changes from one form to another form. So whatever may be the energy we have given, that is converted into the kinetic energy of the electron. So it starts traveling away from the, I mean, it continues to travel in circular path, but little away from the nucleus. Okay, that is when we say that it jumped to the outer shell. Okay, so from this we understand that whenever an electron absorbs energy, it jumps from inner shell to outer shell. In the same way, when electron has to jump back, remember, no electron can stay in the excited state for a longer time. It needs it is coming out in form of an electromagnetic wave. Now that electromagnetic wave also has energy, and that energy is given by the formula E is equal to h nu. Okay, we use the formula E is equal to h nu, where E is the energy that is possessed by the, like the amount of energy that is given out or absorbed. H is Planck's constant, and nu is the frequency of radiation. Now, if the electron is jumping from outer shell to inner shell, then E2, say it is jumping from second shell to first shell. So we write E2 minus E1 will be given by Planck's constant into frequency of radiation. Okay. Similarly, if it is jumping from third shell to second shell, the amount of energy liberated will be different. If it is jumping from fourth shell to third shell, it gives a different amount of energy. Okay, so these energies are coming like a band, an energy group of electromagnetic waves. Okay, so that only we call it as band spectrum. Spectrum could be a new word for you people. Spectrum is nothing but a group of waves with a different wavelengths. Okay, a group of waves carrying energy together, we call it as spectrum. For example, we have visible spectrum of light. That means we are having waves starting from red to violet. These frequencies we can see, our eyes are sensitive to that frequency, so we can see them. So that is coming under visible spectrum. In the same way, we have a huge range of group of waves which can be you, like we can find the energy of that. So that spectrum is again, we have a name. Niels Bohr has given a name. Okay, he classified them into Lyman series, Gamma series, bracket series, fun series, fashion series, depending on from which shell to which shell they are moving. And the process and this spectrum of hydrogen was so beautifully explained by Niels Bohr, for which he was awarded with Nobel Prize. Now, coming to the drawbacks, why is it we have to multiply with h? He doesn't have an answer for that. Why we have to quantize? See, E is equal to h nu is actually Planck's equation. We call h as a Planck's constant and mu is the frequency. Now, why we have to multiply with h? Why we have to quantize that? That is something which we could not explain. This is the beginning. These spectral lines, the group of waves, okay, when they are kept in a magnetic field, they are splitting into individual discrete spectral lines. The splitting of spectral lines in the presence of magnetic field is called Zeeman effect. Zeeman effect. Now, why is this splitting happening? He had no answer for that. Similarly, when we place or when we allow these spectral lines to pass through electric field, there also the same thing happened. Splitting of spectral lines in the presence of electric field is called Stark effect, and that also he could not explain why it is happening. Okay, so he could not account for the formation of bond, how atoms are combining, what kind of bond, like what is, how is this bond formed. He could not explain to the next scientist who put forth his concept of atom is, it was Sommerfeld. Sommerfeld brought about a very little change in the structure of atom, which started justifying many things. Okay, he stated that electrons are not revolving in circular orbits, but they are actually revolving in long elliptical orbits. With this, actually, momentum is conserved. Now, what is this concept of momentum being conserved? If you were thinking that the speed of anything which is moving along circular path is constant, or say not to mention the circular path, okay, if you consider that the path of Earth around the sun is circular, you are wrong. Okay, electrons, planets, these all are not moving in circular paths, but they are actually moving in a long like this. And then after coming here, this is the direction of velocity and this is the direction of force of attraction. So we tend to travel like this. So what happened at every point, the direction is changing. At the same time, the force with which it is being attracted is also increasing. Now, when that force is increasing, automatically what happens? The velocity will increase. Velocity of these planets or electrons is minimum when it is at the major axis, and it is maximum when it is at the minor axis. Now, when I said it is maximum when it is at the minor axis, it is so high that it actually overcomes the force of attraction and it starts moving away. So it moves like this. So the resultant force will be in this direction. So it travels in this direction. So like that, it continues to travel, and slowly by the time it reaches here, the force of attraction is in this direction, so it slows down. By the time it slows down, the only force that is like this centripetal force, which is acting towards the center, will dominate. And as it is dominating, again it tries to move like this. So like that, what happens? The velocity is increasing when it is traveling from one end of the major axis to one end of the minor axis. And then when it is traveling from this end of the minor axis towards the other end of the major axis, the velocity is decreasing. So in this way, the velocity or the momentum is nothing but the product of mass and velocity. So velocity which is gained at one point is lost at the other point. So the total momentum is conserved. This is one more explain, but this model of an atom actually, shell, its orbit is having a suborbit or an orbital. Let me tell you how it goes. Any along the path, in the same circular path, but definitely not along only that path. So it can be anywhere around here. Okay. So that space or region where the possibility of finding an electron is maximum is called orbital. Now, he stated, Sommerfeld stated that electrons are revolving around the nucleus in long elliptical orbits. Okay, and each orbit is having an orbital. So he called them as energy levels and sub-energy levels, which he later named it as shells and subshells, orbits, orbitals. These all are same. Okay, energy levels, sub-energy levels. When you go to higher classes, you are like, it is mandatory for you to call these as energy levels. You should not be using shell or subshell like children, like, up to 10th standard. Yes, you use the word shell and subshell, orbit and orbital. But when you go to higher classes, you should be calling them as energy levels and sub-energy levels, because these all are referring to the energy that is possessed by electrons. Okay. Now, this space or region where the possibility of finding an electron is maximum is called orbital. He also stated that the number of orbitals which are present in an orbit is also dependent on the number of the shell itself. If it is the first shell, that means the shell name is K, then it will be having only one shell. If it is the second shell, that means L, then it will have two subshells. If it is the third shell, it will have three subshells. Okay, that is how he stated. Okay, that is how he explained. Now, he also gave names to these subshells. He named this first subshell as S orbital. Wait, wait, I write here. S orbital. Okay, and I said L will have two subshells, that is S and P orbital. Remember, all are small letters. Okay. M has three subshells, S, P, and d orbital. So like that, depending on the number of the shell, the number of subshells will be varying. Okay. Now he also gave the shapes of the shapes. He predicted the shapes of these orbitals, which was later confirmed. S orbital is spherical in shape. Okay, and p orbital is a dumbbell shape. What is a dumbbell? Dumbbell, is it different from dumbbell shape? Dumbbell actually refers to the shape. If a body is having mass concentrated towards the ends and least mass at the center, we say it is a dumbbell. So students, like some of you might be doing weight training. So wherein you take a weight into your hand and you start working out on your bicep muscles, arm muscles, wrist, okay, shoulder. So what does it have? It has a weights towards the end and there is a rod in the middle. So mass is less at the center and more towards the ends, and that is why it is dumbbell shaped. D dumbbell shaped. So if you have two dumbbells coupled together, then it is d orbital. So like that, he has given shapes of orbitals also. Okay, now we are actually following modern concept of atomic theory, which states almost more or less the same. Okay, atom has a nucleus at the center. Electrons are revolving around the nucleus in long elliptical orbits. Each orbit will be having an orbital. Each orbit will be having orbitals, and the number of orbitals or number of subshells is actually dependent on the number of the shell. Okay, and electrons are present in the subshells, in the orbitals. Okay, quantum numbers. Okay, which will explain us how to write the electronic configuration. Okay, now before that, can like what how do we define electronic configuration? What is electronic configuration? Electronic configuration is nothing but arrangement of electrons in their shells and subshells. So again, I am telling you, science is simple. Let us keep it simple. Electronic configuration is nothing but arrangement of electrons in their shells and subshells. Now, uh, first quantum number that we will be discussing about is principal quantum number. Principal quantum number. Principal quantum number was proposed by Niels Bohr and it is denoted by the letter N. Okay, now this principal quantum number actually gives us the energy that is possessed by the shell. And don't wonder what this N is. Okay, it is very simple. It is nothing but the number of the shell. If we are talking about the first shell, then N value is 1. If we are talking about the second shell, then N value is 2. If we are talking about the third shell, then N value is 3. So, principal quantum number, the name is very long, big and scary, but don't get worried, it is very simple. Principal quantum number is nothing but the number of the shell. So if we know the number of the shell, we can actually find out the energy. We can know the energy that is possessed by the shell. We can know whether it is having more energy or less energy. So we are getting information about the energy possessed by the shell. And it can take values starting from 1, 2, 3, so on. So 1, 2, 3, and value can be anywhere starting from 1, 2, 3, so on up to n. Now, the second quantum number we will talk about is azimuthal quantum number. This azimuthal quantum number was proposed by Sommerfeld. Okay, so when I said it was proposed by Sommerfeld, you should have understood that it has something to do with subshells, because as Sommerfeld was the scientist who proposed about subshells, orbitals. So Sommerfeld initially stated that uh, no, initially represented, he used the letter K, and this azimuthal quantum number gives us the information about the subshell K. Then he said that this K will be taking values as of n. Okay, that means if it will be taking values from 1, 2, 3, so on up to n. Okay, that means we already said if it is the first shell, it will be having one subshell. If it is second shell, it will have two subshells. So that is what it is. Okay, if it is the first shell, then it will have one subshell. If it is in second shell, it has two subshells like that. However, later it was corrected, saying that it is not taking values from 1, 2, 3, so on. It is taking values from 0, 1, 2, 3, so on up to n minus 1. Okay, it is taking values starting from 0, 1, 2, 3, so on up to n minus 1. And later they changed the representation also to L. So L is equal to 0, 1, 2, 3, so on up to n minus 1. So this is azimuthal quantum number. Now let us write the values for this. I said he named these orbitals as S, P, D, F, so on. Now the value of s orbital is 0. Remember, when I write S is equal to 0, I am not saying that the first shell is not having any subshells. First shell is having one orbital, that is s orbital. Till there we are clear, and the value of s orbital is 0. Okay, the value of s orbital, that means the azimuthal quantum number of s orbital is 0. Similarly, p orbital value is 1, d orbital value is 2, f orbital value is 3. So like that, we have got values for orbitals. This is given by azimuthal quantum number. So azimuthal quantum number was proposed by Sommerfeld. It is represented by the letter L. It takes values from 0, 1, 2, 3, so on up to n minus 1. And it is giving us information about the subshells. After this is the magnetic quantum number. Magnetic quantum number. What does this magnetic quantum number mean? Whenever we place these orbitals in a magnetic field, they show some orientation, they deviate, and depending on the energy possessed by them, they change their position or shift their axis. Okay, and how many different orientations can be exhibited by orbital when kept in magnetic field is given by magnetic quantum number, which is denoted by the letter M. Okay, this was given by a scientist named Lend, L-E-N-D, Lend. Now, this takes values like this, 2L plus 1. What does this mean? If it is s orbital, before going into this, let me ask you, shape of s orbital is spherical. Now it is spherical in shape. In any direction I see, does it make any difference? No, right? It does not make any difference. Now let us see how that is represented here. So s orbital, it is having value 0. When this is kept in magnetic field, the magnetic quantum number m, which is given by 2l plus 1, okay. So L value for s orbital is 0. So 2 into 0 plus 1, that is equal to 1. So s orbital has only one orientation. It is spherical in shape. However you turn it, it is not twisting. However you turn it along with any axis you see, it remains the same. That means s orbital has only one orientation. Can also let me tell you, each orientation of an orbital can accommodate 2 electrons. So s orbital can have 2 electrons. It accommodates 2 electrons. Now coming to p orbital. P orbital value is 1 because we went like this: SPDF, SPDF 0, 1, 2, 3, so on for both. Okay. Now p orbital, azimuthal quantum number of p orbital is 1. So when it is kept in magnetic field, the values it should take is 2l plus 1. That is 2 into 1 plus 1. That is 3 values. What are those 3 values? Okay, it can be like the 3 orientations. It can be either along x-axis, along y-axis, or along z-axis. Okay, so that is how we got px, py, and pz. Okay, and also when I said this 12 plus 1 values, it is taking 12 plus 1 values in integers: 0, -1, -2, so on, and +1, +2, so on. Okay, now p orbital has 3 orientations. 3 orientations with each orientation accommodating 2 electrons. So px will have 2 electrons, py will have 2 electrons, pz will have 2 electrons. Altogether 2 plus 2 plus 2, that is 6 electrons it has. Okay, so p orbital accommodates 6 electrons. This is something which we all know. We all know that first shell will have 2 electrons and second shell will have 8 electrons. But how first shell is having 2 electrons? Because it has only one subshell, that is s orbital, and s orbital can accommodate only 2 electrons. Second shell is having 2 subshells, 2 orbitals, s orbital and p orbital. S orbital can accommodate 2 electrons, p orbital accommodates 6 electrons. So 2 plus 6 is making 8 electrons. So second shell will have 8 electrons. Okay. Similarly, third shell will have s, p, and d orbital. D orbital will have how many orientations? Okay, d orbital, azimuthal quantum number is 2. So m is equal to 2 into 2 plus 1, that is 5. That means d orbital has 5 orientations. What are those 5 orientations? dxy, dyz, dzx. If it is in the xy plane, it is dxy. If it is in yz plane, it is dyz. If it is in xz plane, it is dxz. So like that, it is having orientations, okay, along xy, yz, zx, and dx square to y square. If it is in xy plane, we are saying it is xy. If it is along x-axis and y-axis, then it is dx square to y square and dz square. Total 5 orientations it has. So that is about magnetic quantum number. Now coming to the fourth quantum number, that is spin quantum number. spin quantum number. See, the name itself says spin. That means we are referring to the spinning of electrons, S. Okay, it is denoted by the letter S. Now, we always place electrons in pairs. Suppose I said S orbital can accommodate two electrons. Can any two electrons come into S orbital? No. It is not that any two electrons can come and join S orbital or they get accommodated in S orbital. It is not like that. Every single thing, every little contributes to the energy of an atom. For that matter, even the spin of the electron. Okay, spin of the electron also is contributing to the energy of the entire atom. Okay, now if there is only paired up with the other electron which is spinning in anti-clockwise direction, this is, yeah, if there is one electron which is spinning in clockwise direction, there will be another electron which will be spinning in anti-clockwise direction. Only these two electrons can pair up with each other to form an electron pair, or they get accommodated in one orbital. Okay, so the values taken by this are plus half and minus half, either clockwise or anti-clockwise. Simple as that. Okay, now these are the four quantum numbers which we should learn before knowing about how to fill electrons in the shells, and that is what we call electronic configuration. Now, before writing electronic configuration, before knowing about electronic configuration, let us know the rules to be followed while writing electronic configuration. First one, is Aufbau principle. Aufbau principle states that filling up of electrons should take place with those orbitals which are having least n plus L value. Okay, that means all orbitals which are having lowest energy should be filled up first and then the next level. Now, how we will know which is having more energy and which is having less energy? For that, we have a diagram which makes life simple for us. That is called a molar diagram. See, molar diagram goes like this. The orbital which is having least n plus L value is 1s. 1s orbital. After 1s orbital, let me draw it here. 1s orbital. Okay, so first shell is finished. After first shell, second shell, and second shell has two subshells, that is 2s, 2p. Third shell has three subshells, 3s, 3p, 3d. Fourth shell has four subshells, 4s, 4p, 4d, 4f. Next, 5s, 5p, 5d, 5f, 5g, so on. Okay, so we draw lines like this. First, the electron should go into 1s orbital. After 1s orbital is filled, how many electrons can be filled in this 1s orbital? First shell has only s orbital, and s orbital can accommodate only two electrons, so two electrons. Then the third electron should be coming into 2s orbital. After 2s orbital is filled with two electrons, then the next electron should go to 2p, okay, where six electrons get accommodated. After those six electrons are accommodated in 2p orbital, then the electrons enter into 3s. After 3s, electron enters into 3p. After 3p, it goes to 4s. Now see the magic. The electrons are going into fourth shell, After filling the 4s orbital, then they are filling the 3d orbital. After 3d comes 4p, after 4p comes 5s, and after 5s comes 4d. Why is this happening? Look at the n plus L value. We should follow the definition carefully. Electrons will be accommodated in that orbital which is having the least n plus L value first. Okay, so first electron should be going into uh, 4s orbital. Look at this 3p, 4s and 3d. 4s is nothing but 4 is the value of n plus s value is 0. So that is 4. Now what about 3D? Okay, 3D is the value of n is 3. Okay, and D value SPD 0, 1, 2. So 5. Now if you notice, in spite of being in the third shell, it has a more energy. That is the reason why electron is not entering into 3D, but it is going into 4s. Okay, so this is the rule. Okay, the orbital which has the least energy should be filled up first. This is Aufbau principle. Now, after Aufbau principle, this diagram is called a molar diagram. Okay, after Aufbau principle, we have to discuss about Hund's rule. Okay, Hund's rule states that pairing of electrons takes place only after all the available degenerate orbitals are filled with one electron each. Now, what are degenerate orbitals? I will tell you. Suppose we have p orbital. P orbital has three orientations: px, py, pz. Okay. For my convenience, I will represent them like this in form of box. First electron will go into px. The next electron will not fill this px, but it will enter py. And the third electron will go to pz. These orbitals px, py, and pz are called degenerate orbitals because they have the same amount of energy. Orbitals which have the same amount of energy are called degenerate orbitals. Okay. Now all the available degenerate orbitals are filled with one electron each. So now the pairing takes place. The fourth electron which is coming will enter px, which is having an opposite spin, then goes py, and then pz. Like that, pairing of electrons takes place only after all the available degenerate orbitals are filled with one electron each. Okay, so that is Hund's rule. After Hund's rule, we will discuss about Paul's exclusion principle. Paul's exclusion principle states that no two electrons will have all quantum numbers same. Let us see how. See, I have chosen an element, say nitrogen. I took nitrogen, you can take any element. Electronic configuration of nitrogen I will write. Okay, nitrogen atomic number is 7. Okay, its electronic configuration is 7, so it has two shells. Okay, First shell, it has 1s. Second shell, 2s, 2p. Now, first electron will go into 1s. Second electron will go into 1s as well. The third electron will go to 2s. Fourth electron will go to 2s only. Fifth electron, it will go to px. Sixth electron will go to py following Hund's rule. And the seventh electron will go to pz. So all 7 electrons are seen here. 1s2, 2s2, 2p, 3. Those 3 are also 1 in py, sorry, px, 1 in py. The third one is pz. Now, these electrons, I choose any 2 of those. Let me say I chose this electron and this electron. Do they have principal quantum number same? No. Principal quantum number for this is 1, whereas principal quantum number for this is 2. So they don't have quantum numbers same. Fine. I will do one thing. I will choose 2 electrons from this one, 2s orbital. They have principal quantum number same because both are from the second shell. Azimuthal quantum number also same because both electrons are in s orbital only. Okay, magnetic quantum number is the same because s orbital orientation is same. Okay, 1 only, 0 only. Okay, no, s orbital value is azimuthal quantum number is 0, so same. And coming to spin quantum number, one electron is doing clockwise spin, the other electron is doing anti-clockwise spin. So even though 3 quantum numbers are same, the 4th quantum number is not same. Okay, so that is what Pauli's exclusion principle says. No 2 electrons will have all quantum numbers same. Now, following these rules, let us try to write electronic configuration of a few elements. Okay, I would start with hydrogen. What is the atomic number of hydrogen? 1. Okay, so it has one shell. That first shell is having a subshell S, and s orbital can accommodate 2 electrons, but hydrogen atomic number is 1, so only 1 electron. So that is 1s1. Okay. Now coming to helium. Atomic number of helium is 2. Okay. It has first shell. In the first shell, 1 subshell, and s orbital can accommodate 2 electrons, so 2. So it is finished. Now coming to third one, lithium. It is having atomic number 3. So first shell has 1 subshell. Second shell has 2 subshells, 2s and 2p. Okay, let us write in forehand. First shell can accommodate 2 electrons. Now out of 3, 2 electrons are already been accommodated in 1s orbital. Only 1 electron is left, that will go to 2s. So electronic configuration of lithium is 1s2, 2s1. Now beryllium. Electronic configuration is 1s2 because atomic number is 4, 1s2, 2s2. Okay. Now coming to boron. Boron atomic number is 5, 1s2, 2s2, 2p1. Okay. Someone might have got a doubt that this is having 2 electrons filled in the s orbital. If helium, which is having 2 electrons in the s orbital, is stable, it's a noble gas, why not beryllium be stable? Remember, this is in the first shell, this is in the second shell. That shell is not completely filled. Okay. Now coming to carbon. Carbon atomic number is 6. 1s2, 2s2, 2p2. So like this, we can write the electronic configuration of any element. Okay. So I hope my class today, my attempt today is useful to you. Okay. Let us meet with another topic after a few days. Until then, have a nice time. Bye bye.